The safe handling of chemicals is very important. Before starting any experiment, you as students should become familiar with all of the properties of the chemicals being used.
You can find special handling precautions in a variety of books or catalogs and even on the bottle. Once you begin experiments in the lab, some chemicals will require special handling techniques.
It is important to develop the habit of reading the labels on reagent bottles to note any warnings given. Shown here are some important Wemyss symbols which may be on a label. Develop an important habit. Read the label. Another important habit. Before setting up any organic experiment, check the experimental procedure for warnings about chemicals, then think, are any of the chemicals particularly corrosive? If so, wear adequate eye and hand protection. Are any of the chemicals especially flammable? If so, check that there are no open flames in the vicinity. Are any of the reagents toxic or unpleasant smelling? If so, they will need to be dispensed and used in a fume hood. Are any of the reagents highly air or moisture sensitive? If so, special handling techniques will be required. Remember, if in any doubt about how to handle a given compound, ask. Organic chemistry experiments use defined amounts of reagents. The amount of solid for a chemical reaction is always given by weight. In your experiment, you will probably need to weigh one or more reagents and, of course, the final product. The accuracy of weighing required depends on the scale of the reaction. In our laboratories, weighing to the nearest 1/10 gram is sufficient, and in cases where the amount of reagent is not critical, to the nearest gram. A schematic diagram of a modern digital readout balance is shown here. It has a single pan and an electronic zero, which makes pre-weight of containers unnecessary. The important parts of this type of balance include the weighing pan, the on-off control, the calibration control, the tare control, and the weight display. The weight display shows the weight as hundredths of a gram, while the digital display gives several other types of messages. To demonstrate how to weigh a solid and use this electronic balance, we are using reagent sand. You also need a spatula to remove the compound from the reagent bottle, a weighing container such as a watch glass, vial, or perhaps a beaker, or weighing paper, and a flask for receiving the weighed compound. Turn the balance on by pressing the on-off or the tare control. After an automatic test of functions, the digital display shows 0 grams. Place the weighing container, a beaker in this case, on the weighing pan. Zero the weight display by pressing the tare control. Remove the beaker from the balance. It is important to use an appropriately sized container for weighing your sample. In this example, we need about 1 gram of compound, so we will use a tared vial for the remainder of the demonstration. Read the name of the chemical on the reagent bottle. Remove the top of the container. Remove the chemical using a scupula or spatula and add some material to the tared vial. Replace the vial on the balance pan and weigh the sample. The weight is 0.8 grams. If there is too much, or as in this case, too little compound, remove the container and adjust the amount of compound. Return the container to the balance and weigh again 1.04, about 1 gram. Do not add chemical to the weighing container while it is on the balance. Remove the weighing container and weighed reagent from the weighing pan. Zero the weight display by pressing the tare control. Replace the lid on the reagent bottle and record the weight in your lab notebook. Finally, tidy the balance area before leaving. If you are using weighing paper, follow a similar procedure. Turn on the balance. Fold the paper in half diagonally. Filter paper should not be used because reagents adhere to it. Place the weighing paper on the balance and press the tare control. Remove the paper from the balance and add reagent. Return the paper and compound to the balance and weigh again. Record the weight accurately. Finally, transfer the compound into your reaction flask. The proper method to transfer a solid uses a powder funnel or creased paper. Do not use filter paper. The corner of the crease is rested over the mouth of the flask, and the reagent is pushed into the flask with the aid of a spatula. Liquids can be measured by weight, but it is usually easier to measure a liquid by volume. Various equipment available in the laboratory is suitable for measuring the volume of liquids. Beakers and Erlenmeyer flasks have approximate volumes marked on their sides, while graduated cylinders measure more accurately. The choice of equipment depends on the accuracy of measurement required. If about 60 milliliters of solvent is required for an extraction, for example, then a graduated beaker or Erlenmeyer flask can be used. When more accuracy is needed, use a graduated cylinder, but choose one of appropriate size. To determine the volume, read the liquid measurement from the bottom of the meniscus. In this case, it is 4.6 milliliters. When measuring liquids, it is possible to pour liquids from a reagent bottle into a measuring cylinder, but a funnel should always be used to minimize the chance of spills. One technique, which also helps to prevent spills, is to pour the liquid down a glass rod. Never attempt to pour a small amount of liquid, say 7 milliliters, from a wide-necked Winchester bottle into a 10 milliliter measuring cylinder. Use a clean pasture pipette to transfer the liquid. In our labs, some liquids are dispensed through automatic pipettes. There are 3 kinds of dispensers seen here. The containers with blue and pink solutions are dispenser bottles for pouring various amounts of reagents, while the brown container has an automatic dispensette and is used to measure 2 to 10 milliliters of liquid. This dispenser bottle is designed to have the top squeezed. However, you get better control by squeezing the sides. I recommend that you do it this way. With this container, you simply pour the reagent out the large spigot. The other tube is a vent to let in air. With the automatic Brinkmann dispensette, first set the amount of liquid required, say 5 milliliters. Loosen the screw, move it to 5 milliliters, then tighten finger tight. With the discharge tube pointing away from you, hold the vessel under the discharge tube. Pull the plunger up gently to the upper stop. Push down gently and evenly. Be careful. Never force the plunger. Never raise too quickly or push too hard. The replacement cost on this item could lead to personal bankruptcy. With the dispenser 511, set the desired volume, say 2.5 milliliters, with the volume selector. Rotate the selector until the desired number appears in the window, 2 in this case. It automatically clicks in at the right position. Rotate the collar until the 5 stands next to the window. The correct position is achieved when the white dash under the window is even with the vernier graduation mark. Raise the plunger to fill the dispenser barrel. Gently push down to deliver the liquid. After use, place the tip cap on the delivery jet to prevent liquid from leaking.
Although experiments are designed to teach proper and safe technique, some may deal with dangerous material. Ultimately, safety depends on you. Be aware. Read labels and follow all safety instructions.